Hey, John Gilroy here. You know, my mama always told me to respect my elders. Well, I got one right in front of me. Patrick Elder, Director of Data and AI from ECS. Hit the music, Manny.
Welcome to the Federal Tech Podcast, where industry leaders share insights on innovation with a focus on reducing cost and improving security for federal technology. If you like the Federal Tech Podcast, please support us by giving us a rating and review on Apple Podcast.
Welcome to the Federal Tech Podcast. My name is John Gilroy, and I'll be your moderator. In the studio today, we have Patrick Elder, Director of Data and AI at a company called ECS. More information at ecstech.com. And today, we're going to talk about explainable AI. However, before we begin, I would be remiss if I didn't tell the audience that we are recording this from Monk's Barbecue in lovely downtown Percival, Virginia. This has got such a high-class place. When I look up over my head, there's a light fixture made out of an empty whiskey bottle. Is that true, Patrick?
It sure is. I've never seen anything quite like it, but, unique podcasting experiences.
It's a unique podcasting experience, I guarantee you that much. I have a friend named Jason Miller who writes for a federal news network, and I'm going to quote him, and then we'll toss to you, and you can maybe respond to that and maybe make some observations. He wrote, I think, yesterday that the Labor Department is using AI to make compensation more accurate. The Census Bureau is using AI to crunch massive data sets. We got a theme here, don't we? OPM is using AI to update 30-year-old position descriptions. Patrick, we have a theme here?
Well, it seems like AI might be exploding in its usage in the federal government, but, that's just one man's opinion.
Yeah, I was researching the topic, and I stumbled on a blog at ecstech.com, and I read it, and it was titled Explainable AI, and I said, well, finally, I want someone to explain it to me. And it's written by a guy named Patrick Elder. So I contacted you and said, come on down to Monk's.
And how could I say no with an invitation like that?
Well, our previous guest was David Linthicum. He's just written a book, and I asked him, well, why'd you write the book, Dave? He gave me an answer. So, Patrick, I got to guess the same question. So why did you write this article? What was the need?
So I think one of the things that made us want to talk about this is, as we're seeing this explosion of AI and its usage in the federal government, a lot of times we're seeing our customers and our colleagues asking, well, how do I know how this thing came to the decision that it made? When we look at the federal government, we need to know how decisions are made. That's the basis behind the Evidence Act. It's something that we demand from our lawmakers and our public servants. We couldn't just wake up one day, make a decision, and say, "Hey, that's how I was feeling." We as the public, demand that we have this kind of explainability and be able to trace what it is that made us come to the decision that we did. And so if we're going to be using AI to help automate and streamline and improve the way we make decisions, we need to be able to explain how those decisions were made.
I love the fact that David was just sitting in the chair you were at a half hour ago. So I got to push some things on you here. In his book, David Linthicum says AI and ML are old concepts with a new life thanks to cloud computing. So you agree with that?
I do. If you think about it, a lot of the algorithms that we're using now to help us make decisions and automate heavily manual processes, they've been around for hundreds of years, maybe even thousands. It's based on math that's been around for a very long time, but couldn't be done at scale without the kind of compute and data that's available within the cloud. So I completely agree with that sentiment. It's something that's going to continue to explode and evolve now that we have access to these tools.
I'm going to go back to Dave Linthicum here because this is so many profound things in our interview. When it talks about AI, he said that AI is the single most valuable thing you can do in the cloud today. Wow. That's a strong statement, isn't it?
Bold statement. I think right now that may be loaded because that's a place of very high investment and something that I think we see as an opportunity to really improve the value that every single one of us can give in our roles and as we do our work from our day to day. The opportunity to automate a lot of things that were not possible with simple programming methods and other things like that because it required a higher level of compute and understanding that we traditionally relied on the human brain for. And I think now we've got an opportunity to take everyone, to basically have their own team of interns working with them as we're able to apply these techniques and some of these tools that are available. It's a really exciting time. So I think that's where that value comes from as far as what you can do in the cloud. Whether I'll say that will always be the case, I'll hold judgment there.
Well, Patrick, I hope you bring some barbecue home for your wife this evening. And while you're relaxing around your house, you may turn on Netflix, and maybe the last 10 most popular movies involved artificial intelligence and robots and the end of the world and aliens. I don't know. It seems to be everywhere. So I looked up a quote on this, and this is a concern that many people have when it comes to artificial intelligence. A gentleman by the name of Tristan Harris, he works for the Center for Human Technology. And here's the quote. 50% of researchers believe there's a 10% chance humans will grow extinct from our inability to control AI. Now, I want to burn that quote, but I have to ask you, am I off base? Does this sound like it's wildly exaggerated?
I think this is one of those things that anybody can make up a statistic. 98% of all people know that. Sure, if we want to make a point by throwing out a number like that, that's great. I'm sure that there is a statistical probability or possibility that could happen. I think it's pretty unlikely. One of the things that we're trying to do, in general, both in the private and the public sector, is get a greater handle on what is appropriate use of AI, what guardrails do we need to put around it, and also how to protect ourselves, because there are bad actors out there and they have access to the same technology. So how do we use AI to defend AI? And how do we use AI to defend ourselves?
Well, I want to go to East Palestine, Ohio now. Where's this coming in? And the railroad. The railroad? If you read about what happened in East Palestine, there was a hot box in the train, and it wasn't detected. And I don't want to talk about hot boxes. I want to talk about different types of boxes, the boxes you mentioned in your article. I want to talk about a glass box and a white box and a black box. And I know what a hot box is, but what are these boxes you're talking about?
Sure, and so when we talk about that, it's really the way that we categorize the different kinds of AI and ML models. Most of the time when you look at publications across the internet, you're going to just see your glass box and your black box models. Mm-hmm. Basically, it's kind of like it sounds. The glass box models, you can see exactly how it's working. It's very easy to interpret and explain how the data that you put into it got you your result. Whereas with your black box models, you have no idea. These are generally like your deep learning neural networks where you put stuff in, you get an answer. Most of the time it's pretty good, but you're not really sure how it got there. What we talk about with some of the white box models is where this stuff starts to fall in between. You have some interpretability, you have some a way to understand how the features that you've input into the model gave you your answer, but you may not be able to necessarily explain each individual decision. And that's another clear distinction that we made in this blog, is that there's a difference between interpretability and explainability. Those two terms tend to get conflated with a lot of the articles and some of the publications that we were looking into while we were doing our research. And interpretability is really, in a general sense, how the features that you add to a model, the data that you put into it, impact the decision or the output and what comes out of it. Explainability is something that I think is more important, especially for the federal government and the public sector, because that's the ability to explain a single decision. So if this were, hey, this person should be hired or not, we should put this person through the next round of interviews, that funding should go this way. We need to be able to explain why that decision was made, just like we do now when humans are making those decisions.
So there's no gray box. You didn't go with gray,
We didn't go with gray box. I'm sure we could have, shoehorned that in there if we really wanted to, but, why make it more complicated? People like threes.
Now, I would imagine that one of the reasons behind transparency is because it is quite possible that mere mortals like me may use data sets that are biased, or data sets that are inaccurate, or data sets that are wildly inaccurate. And so if I come up with a conclusion that we should buy X, I can say, well, AI determined that. Well, what data sets? And this is the debate. I imagine this is a debate you have every single day is, oh, really? Well, let's talk about biases there. So is that a concern you have?
Absolutely, and I think this is one of those things, as you talk about explainability and interpretability, that can help you improve your model. You can start to identify the bias that exists from the features that you've used, from the data that you've trained on. Sometimes there is a matter of there is no data that is going to give you your non-biased answer. So how do you create that? How do you do that in an ethical way, which is an entirely separate part of AI and ML, that creating synthetic data that is unbiased, that's allowing you to create these models that are less biased. And also for the decision makers, AI and ML models should be tools that you use to make a decision. They shouldn't be making the decision for you. So where that human in the loop sits, your ability to look at the decision that was made, the information that it used to make that decision, and then whether or not you want to go along with that or adjust.
We're recording this from a barbecue place in Purcellville, and I love having documents. I can't do this in Zoom, it's too awkward. But ladies and gentlemen of the jury, I have Exhibit A in front of me right here, and and the Exhibit I have, Patrick, is the AI Bill of Rights. Mm-hmm. And this is from October 2022 from a little place called the White House. So this isn't something that someone just came up with while they're driving to work one day. So are you familiar with this, and what role does this have in the work that you're doing with AI?
Yeah, have definitely reviewed it a couple times. I think also some of the stuff that's come out of the EU as far as Bill of Rights for personal data and how it's used. I think the risk management framework for NIST is another thing that we need to consider as we're going to start using these things in the federal government. I think it's all about the use of data. I think this is the thing that we hear about the most when we look at the explosion of generative AI and OpenAI's ChatGPT. The fear among the public sector, the private sector, and just the public in general, what's happening to my data when I put it in this thing? They get to use it for whatever they want. And I think the importance of privacy and data security is something that's been elevated as a part of this. I think that's something that we're trying to spell out in a way within these documents, these Bill of Rights, risk management framework. How do you develop effective AI while protecting the privacy of the data that you're going to use to train these models?
Well, we've touched on some of the sophisticated aspects of this, but I want to get down to the nuts and bolts, down to the dollars and cents of it, and this is the dollars and cents that a lot of people aren't talking about, There's a lot of cost involved in AI, and getting a decision may be much more expensive than you realize. It may be biased. So what kind of factors do you include in using AI? Factors like storage, compute, databases, security? I mean, this has to come into you don't flip a button and AI is there. I mean, there's costs involved.
Yeah, and I think that boils down to your use case. Sometimes you've got cases where there has been a lot of cost and expense and human labor put into developing the model, but that model is pretty baked, and you can use it without a lot of extra compute. The hard work has been done, so to speak. In other cases, you're going to want to develop something on your own, and that's when you're talking more about, do I have enough data to do this? Do I have enough compute? Do I have enough storage? And does that then justify the cost of creating this? Well, can I put a number on the amount of hours that will be reduced in human beings working on this stuff by automating it or creating a model with AI? You also have to be thinking about, what does the maintenance of that model look like? You can't put these things into production and expect them to work forever. Data change, people change, environments change. There's always something new to learn, and so there's the upkeep of those models that you have to also consider when you're thinking about starting an AI project like that.
Is there a possibility that AI can be overused or not used appropriately? In other words, if I want to turn a wrench on my bicycle in the garage, I'm not going to go to the Sears and get one of those big 200-piece wrench sets. I may just need a 9/16 or 10-millimeter wrench. And so is it possible there may be government agencies that actually are using it for the wrong reasons or overkill?
Well, I don't want to say using it for the wrong reasons. I think one of the things that we're dealing with right now is that AI is the shiny new toy, and everybody wants to use it. I think a lot of times as we take a harder look at what it is that we're trying to solve, what's the business use case, what is the thing that we're trying to take from pain to pleasure, whatever it is, use the right tool. There are a lot of different kinds of AI and ML that can be used for different purposes, and some of those are not sophisticated, they're not expensive to develop, but they can be very effective given the right amount of data and the right kind of use case. We look at some of these other ones that are more expensive to generate, that take the heavy compute time, that have less explainability. There are correct use cases for those too. And so I think it's understanding what these are good at, what they're doing, and when it's okay to have something that isn't explainable versus when you have to have something that is.
Was it Rumsfeld that said some things you don't know that you don't know? Mm-hmm. And there may be use cases that you just don't know. Mm-hmm. 15 years ago, no one knew what a container was, and container orchestration was some kind of a dream, mm-hmm. maybe not even a dream back then. So use cases in the federal government can be more difficult to derive than you think, isn't it? Because they may not realize, I never know I had to worry about this type of a flood in this area where it never happened before.
Right, and I think sometimes as you start to work these things, just like any problem that you're working on, you're going to come across this stuff. You're going to learn. That's a big reason that agile methodologies have become popular, because you don't know everything when you start a project, and things are going to change throughout the development and the life cycle of anything that you're developing, and AI is no different. As you learn these things, you should be able to pivot. You should be able to upgrade. You should be able to improve what it is that you're doing. And you look at all the models that you're seeing in the news, they're continually updating. They're continually trying to improve. It's more data, or it's different data, or it's different kinds of parameters. It's a slightly different algorithm. There's always going to be improvements that you can make. So as you look at the concept of maybe going overkill or maybe overdoing it, look for the right use case, find the right models, try different things, and then mature, because you can also come across abilities to build upon these things, chain them together, so you can use simplified models in a series to achieve better results than just one by itself.
Patrick, earlier in the interview, I asked the big why question, why I wrote the article. But my little brain's working here, and I'm imagining that maybe you were in the Pentagon in a general's office, and the general pounded on the table and said, bang, 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 bang. Show me the results, and how'd you get this, and why? I'm just not going to accept this as something. I mean, was that what happened, or was there some federal agent said, that ain't good enough, Patrick? Show me your work.
Honestly, no. I think as we were looking at these documents, like the Bill of Rights, and some of these other things that we've already touched on, we're realizing there's a need for this, because people are asking us, how do you do AI? And we needed to kind of take a stance on, this is how we would do explainable AI. When explainability matters, this is how we would do it. These are the techniques that are out there. Understand the risks, help us, establish ourselves as leaders to help our customers understand what these things are good at and what they're not, what's the appropriate use case for this, and how to get to explainability for the things that really matter.
And I would imagine if you go category by category or silo by silo, there may be individuals who will pound on the table and demand, explain everything, and the white box, the gray box, whatever box you happen to use. Some aren't going to be that important. For example, let's just throw out popular topics, I'm sure if you went to Google Trends and typed in some words, you'd see some peaks, not peaks. For example, deep learning, fraud detection, training data. I mean, there are different areas that it's more important than others, especially if it's fraud detection, because if there's going to be some kind of a legal action involved, there's going to have to be some explanation there for the court's use. Now, if it's someone where they're trying to decide what kind of toner to buy, it's not going to be there. But for legal actions, fraud detection, you have to be more serious about this, don't you?
Yeah, absolutely. And I think a great example of where it doesn't matter is one that you mentioned earlier. When you go to Netflix and you get suggestions for the next thing to watch, who cares how it came up with it? Is it right or not? That's all I care about.
Yeah.
In other cases, you do need to be able to explain it. And the legal one is the most obvious to me, because we have to be able to trace back. This has to hold up in a court of law. We would not want to be setting precedents where we're just going to trust the machine, because we're affecting people's lives. And I think that is one of the things, particularly in the public sector, it's not just the legal aspects of this, but it's how we serve the American public, how we protect the American public. Those decisions need to be explainable. We need to be able to tell the person that had the decision made using this technology, this is why we came to this conclusion. You may not agree with it, but we can at least explain why we did what we did.
Yeah, and I think it's at the point now, with the massive amounts of data that everyone's have to handle, they realize that we can't send Patrick in the back of the room with an Excel spreadsheet and have him come up with an answer. It's just, it'd take 20 years.
Yeah, exactly.
Or 20 Patrick's 20 years. And so at some point in time, you have to trust the data, and I think that's why this blueprint for an AI Bill of Rights is there. It's a preliminary step in just trying to figure out what data hot topic on COVID. Yeah. Which data do you believe? Which data you don't believe? How did you generate that data? Why? And is it biased, not biased? I mean, I think this is a maturity model that people are looking at now, where earlier days it was, wow, a petabyte. Wow, that's great. Now people say, what's in that petabyte? Mm-hmm.
Yeah, I think so, and COVID's a great example, because as we started to look at that, people started to ask, well, what data did you use? Just like you said there, and people wanted to go and look at that. That's why we have data.gov. That's why we make our data that we use for a lot of the publicly available statistics to our constituency, so they can go and analyze that themselves. And, I think as we're looking at this data growing, as you talked about, there's no way that a single person is going to be able to do all this, but there are technologies that help you try to come up with explanations for some of the black box type algorithms. They are essentially trying to run an algorithm on an algorithm's results. So we're going a little meta there, but it does have some, it gives us some assistance to try to figure out how that particular model came to its decision. It's imperfect, but one of the other things that we're seeing in industry as well is creating new kinds of model techniques that are explainable, that do have something that is a little bit more like a glass box type of situation where we can look at the weights in this formula and understand what features are really driving this particular decision. That's really exciting, I think.
Patrick, we have a high school about a mile from here, and I'm sure if you interviewed students, they'd all know about ChatGPT. And I'm not really impressed with ChatGPT, and there's other types of AI out there for the general consumption. So I would imagine there's different types of AI for sophisticated software developers as well. And I combine this with this whole idea of the software development lifecycle. Well, maybe there's an AI model development lifecycle, and you kind of mentioned it earlier about that. So how does one know what flavor, what part of artificial intelligence one is using, and how can he ask the right questions about the origin of your black box or white box data?
Yeah, I think you're absolutely right. There's definitely a life cycle to AI development. There's a life cycle to AI maintenance as well. But what we think about, the thing that I usually try to help people understand when we're talking about different kinds of models is what is it that this thing actually does, and how do you use it? When you think of things like ChatGPT, those large language models are predicting the next word in a string of words. That is what it does. So explaining what it does and the results that it got, looking at it for accuracy, you're asking the wrong question, because this is generating a string of words. So to explain what it did, it would tell you how it generated a string of words. It's not intended to be based on a factual type of thing. So when you look at something like that, if I need to generate text, use the LLM, use ChatGPT to generate me some text, but I've got to go do my homework to make sure that this is actually accurate. Do I need to give that a little context to make it look a little bit more like what I want? Sure, that's one way to do it. But if you're looking for something that's really specifically accurate, there are other models that you can use for that. ChatGPT is really bad at doing simple arithmetic because that's not what it's intended to be used for.
Well, we all survived COVID, I think, most of us. And one of the lessons learned was the amount of fraud that took place. I mean, it's millions and millions of dollars. So is this a use case for updated AI, fraud detection?
Absolutely. So I think we're already using AI and ML to detect fraud. That is a huge use case as it exists now. But one of the challenges that exists for trying to develop models like that is there's a lack of data, because fraudulent events are very small in the grand scheme of things. There are not a lot of those. You might have billions of transactions that are legitimate, and in that maybe 100 that are fraudulent. So trying to come up with a profile for that, trying to develop models on such a small sample against what would be effectively noise in this scenario makes that really challenging. And so one of the things that I think is really exciting is the ability to create synthetic data using AI, developing some larger sample based on some of the information that you already have to give the models that need a lot of data in order to be well trained that set of data, but with that being distinctly different from the real data. Which is also valuable because that's something that you can pass on to any network, to any user to go and develop stuff. You're not putting anything that's sensitive on its own out there for developers to try to work with. So, it helps reduce the fraud and data leakage as well.
Synthetic data, some old guy like me would say operating in a sandbox, and maybe youngsters like you would say, no, this is synthetic. But the idea is that you can take and perhaps even partially anonymize data and look at things and make general conclusions, and then maybe the next step is, okay, Patrick, show me the work, and then you can go back to the real stuff. It could be, it's a waste of time, and so anonymizing data and creating synthetic can prevent wasting time of highly paid data scientists and data analysts.
Yeah, and I think the other thing about it, it's less about wasting time, in my opinion. I think that what we realize when we try to come up with scrub data or sample data to use is it's complex. The rules around our data and how it's collected and what it looks like and how we know that it's good or not good, it's more complex than we might think. And as we start to pull back the covers and the different layers of the onion to mix metaphors, you start to find out it's really hard to do this. And so to do that programmatically is something that generally doesn't bear fruit. But you have something sophisticated like an AI model that could look at a data profile and create a bunch of synthetic data to help scratch that itch, and then we've got safe data to go use in development.
I get up early this morning, I went to Google Trends, typed in artificial intelligence, and it's been around forever. It's been a long, long time. I mean, now we see this big spike, and it's going to drastically increase on that. It would just seem to me that there's going to have to be some kind of a committee, a standards body. Maybe it's going to be NIST, maybe it's going to be somebody, but they're going to have to be people that talk to people like you who've been down in the weeds that can provide valuable information on some of the guidance here. Because I just don't see any kind of best practices here, guidebook, handbook, and we see the risk management framework, but that framework is pretty minimal. I mean, these are rapidly developing circumstances, and it just seems there has to be some kind of a data scientist with a PhD, but you got to have 10 and 20 people like you who've been down in the trenches and learn exactly what's going on. Because I would imagine someone like you could look at a data set and go, nah, something's fishy about that. I got my suspicions that they do this and that and this, and there's just some intuitive aspects of this too. I think there's got to be there. Just looking at data sets all day long, you got to have some feelings.
Yeah, I think this comes down to the context is such a big thing, and understanding the nuance of that data set itself. What industry is it from? What company is it from? What group is it from? Because those things may not be obvious to the data scientists that you hire off of the street. They're going to go off of this and say, okay, this is my gospel. This is what I'm going to go work off of, and they're going to develop stuff that works with that data set. But if you have somebody who has that institutional knowledge that can back up a data scientist and look at this stuff and say that's not right, this record is erroneous, this is poor quality, these missing values were imputed with an average, so put that into consideration while you're developing. Those are the things that are really helpful, and I think that marriage of institutional knowledge and the technical knowledge is something that I think a lot of organizations struggle to find, because data science, relatively new area of expertise. So we're getting an explosion of people that have that expertise, but less that have the institutional knowledge. And so I think tying that together is how we help develop better models, but also better best practices. And things that we can share across industry and across the public and private sectors to create better models and create better outcomes.
So let's talk about ECS. So what is a specialty that your company has, or is this just new expertise you're developing, or what is the focus of most of the programs that your company's involved in?
So we have a large portfolio. Data and AI is one of our focal areas. It's one of our biggest points where we want to try to continue to grow. As of 2023, we were the largest provider of AI to the DoD, according to Delta. But there's a lot of growth happening right now. I think those numbers are going to change drastically year to year because there's so much investment in AI and how we categorize it. But I think, among data and AI, we also focus on cyber and cloud management and modernization. We do a lot of things for our federal partners. Data and AI is a big one, obviously a very important one to me because that's my job. But a lot of great talent at ECS. We're able to pull these areas of expertise together because I think one of the other things that we often don't think about when we talk about these technologies and tools is the organizational change management that's involved in order to create these newer and more modern structures and infrastructure that allow us to use data more effectively.
Right. Your article talks about XAI. Well, there was no stinking XAI 5 years ago. It's like, wait a minute, there's no category for this. It's a brand new category. And so there has to be kind of a fluid, take the word dynamic from the technical and put it into a conceptual perspective of, yes, it has to be conceptually dynamic to understand what's going on because it's just changing too fast. I mean, just look at ChatGPT from a year ago. No one used that phrase.
Exactly.
Now it's every high school person in the world's doing it.
Yeah, and because of the explosion of the ability to use cloud technologies, much like we were talking about earlier, the ability to use these deep learning neural networks for things beyond very focused and highly leveraged situations where they can turn in a lot of dollar figures assigned with them right away was not something that we could do. But now that's available. That that level, that scale of technology and compute is available to us, we can do anything we want with these different, more complex models. So now we have to answer the question of should we?
And that's where the explainable comes in, doesn't it? Yeah. Well, I think you've done a lot of explaining in this interview.
I hope we covered it well.
You have been listening to the Federal Tech Podcast with John Gilroy. I would like to thank my guest, Patrick Elder, Director of Data and AI at ECS.
Thanks for listening to the Federal Tech Podcast. If you like the Federal Tech Podcast, please support us by giving us a rating and review on Apple Podcast.